Now let's talk about correlational research. The idea behind correlational research is that it measures the direction and the strength of a relationship between two variables. Both those variables have values that can vary, like a person's height or weight. And then you conduct a statistical analysis, which is called the correlation coefficient, which compares the values of one variable to those of another. This leads to three possible outcomes. There can be a positive correlation, that is, high levels of one variable are associated with high levels of the other variable. So, for example, as people get taller, they also tend to get heavier. So, if you have a person of a high height, then it's likely that they're also going to have a fairly high weight. Or at least that's how it works when you look at large populations of individuals. It's also possible you could have a negative correlation. So, for example, high values on one variable tend to be associated with low variables on another. So, for example, high levels of alcohol consumption among college students are often associated with low grade point average. So you've got high alcohol consumption and low grade point average. That's a negative correlation. And then sometimes there's really not a correlation at all, what we call zero correlation. And that's when two variables really don't have a systematic relationship between each other. So knowing the value of one variable really doesn't tell you much about the value of the other variable. So here's an example of this. In the left-hand side, you have a positive correlation. And as you can see, you can sort of grab or draw a line. It's not a very good line, but you can draw a line sort of between the points here. Let me try that again. Let's draw a better line. That's a better line between the points. It's not supposed to go cattywampus all through here. So you can see that if you sort of started at the beginning and went through the end and so forth, you could draw a line, but these points aren't directly on the line. It shows that as variable x, hours of studying per week, gets higher, so does your grade point average get higher. Although it's not a perfect, as you can see, correlation. Here's a negative correlation. You can draw a line through here too, sort of. It's not a great line. I need to work on my lines here. But in this particular case, a low hours of TV watched per week tends to lead to a higher grade point average or be associated with a higher grade point average. Similarly, lots of TV watching is often associated with lower GPAs. Sorry about those lines, guys. But they're supposed to be straight, just so you know. So how is correlation expressed? It basically measures strength and direction of a relationship. And a correlation can be a number anywhere between positive 1 and negative 1. If it's 0, or if it's really close to 0, then that association is weak or non-existent. That is, there's probably not a correlation at all. If it's positive 1, there's a perfect positive correlation. And if it's negative 1, it's a perfect negative correlation. So what that means is sort of as one variable increases, the other increases perfectly. If it's a positive correlation, and if it's a negative perfect correlation, then as one decreases, the other increases. Importantly, the strength of a correlation, that is the strength of the correlation, isn't influenced by its sign. So a correlation of negative 0.67 is actually stronger than a correlation of positive 0.32. That is, if there's a real strong correlation like negative 0.67, knowing something about one variable tells us about the value on another variable, where it doesn't do that quite as much on a score of 0.32. So here's a look at what some of these things look like graphically. Here's a situation in which you have a perfect negative relationship. That is, you can think about all of those dots, all of those data points falling directly on this line. So that as x increases, or as y increases, x decreases. This is a moderate negative relationship. That is, again, you could probably draw a line through here that looks like that. That shows it's kind of going down. On the other hand, here, if I drew a line up this way, it's really not much better than a line going down that way. And as a result, you can't really detect. It's kind of a scattered kind of set of data. There's no relationship. Here's a perfect positive relationship over here and a moderate positive relationship here. Again, those dots aren't perfectly on the line. So that's kind of the idea behind the correlation coefficient. Now, the correlation coefficient has its limitations, though. So sometimes a third variable can be responsible for a correlation. It's not just between the two. So, for example, people have studied things like video games and aggression for quite a long time. So let's go into this a little bit in detail. For example, if being bullied could be a third variable that predicts both choice of violent games and a tendency to be aggressive at school. So, for example, imagine we had this correlation between choice of video game. That is, if I choose one that's highly aggressive, maybe I tend to act out at school too. But it's also the possibility that doing something like being bullied increases the likelihood of me choosing a more aggressive game and may increase the likelihood of me being aggressive at school. So here's a situation where it's not the choice of video game. I got to learn not to do that. Let's do that again. It's not the choice of video game that's causing the aggression. Instead, it's being bullied that's causing both aggression and choice of video game. So the possibility of third variables is just one of the reasons to be careful when we reach conclusions based on correlational data. You'll often hear the phrase used that correlation is not causation. And you can see that here. The choice of video game did not cause the aggression. And in fact, it was just correlated with it. But something else, like being bullied, perhaps caused both the aggression and the choice of video game. So I'll go back and I'll leave this here as a discussion, just a quick discussion anyway, of correlation.